Gödel, Cantor, and the foundations of mathematical logic. Mathematical logic is the branch of mathematics that helps us understand how ideas fit together and how we can be sure something is true. At the beginning of the 20th century, around 1900 to 1920, many mathematicians were trying to build strong and clear foundations for all of mathematics. This period was full of new discoveries and surprising ideas that changed the way we think about numbers, infinity, and even what it means for something to be provable. Georg Cantor, who worked mainly in the late 1800s and early 1900s, introduced a completely new way to think about infinity. Before Cantor, people believed infinity was just one single idea, but Cantor showed that some infinite sets are actually bigger than others. For example, the set of whole numbers is infinite, but the set of all real numbers is an even larger infinity. His work created set theory, which became a key language for modern mathematics. Cantor's ideas were revolutionary. Set theory helped mathematicians describe numbers, shapes, and structures in a precise way. Even though his ideas were initially controversial, they became the foundation for many discoveries in the early 1900s, shaping the development of logic during the 1900–1920 period. A few years later, in the 1920s and 1930s, Kurt Gödel continued the search for solid foundations in mathematics. He studied how logical systems work and how we can use them to prove statements. At a very young age, Gödel made one of the most important discoveries in the history of logic. Gödel proved the incompleteness theorems, showing something surprising. In any logical system strong enough to describe numbers, there will always be true statements that cannot be proven within that system. This meant that mathematics, no matter how powerful, has natural limits. His work completely changed our understanding of what mathematical truth means. Together, Cantor and Gödel helped shape the foundations of modern logic. Their discoveries showed both the strength and the mystery of mathematics, inspiring the development of the full mathematical systems we use today.